Hello to my wonderful Algebra 2 class. I am so glad that you're joining me on this Monday. I know you have nothing more that you would prefer to do than algebra, right? What do you mean, no? You'd much rather do anything but algebra? Well, I've got a solution for you. You can go ahead and come to my house and clean for me. That would just be great. Too bad I can't swap that for good grades in algebra. But let's go ahead and get started. But first, can you tell me why the sheep crossed the road? Well, he did that so he could get to the Baba shop on the other side. So, you should be not minding this homework too much. This is a very nice review of what we've done in Algebra 1. What we're going to do today is we're going to continue with solving linear statements. Section 2.1 was solving linear equalities, where you have one side, whatever the value is set equal to the value on the other side. In section 2.2, the title is Linear Equalities, and he starts off with a statement that says, inequalities are all around us. And a good example of that, I mean, that's just what life is. We hear this all of the time. We say, oh, it's just not fair that so-and-so got to do this and I didn't get to do the other thing. Well, what we see and what we know in life is that things aren't really fair. And the idea of inequalities, mathematical inequalities, just is a picture of what life is actually like. All of us have been given different giftings and different abilities. Some of us are good in math, some of us are good in science, some of us have more authority, some of us have less authority. And the sooner that we realize that things are not equal in life, that things are unequal, but that it's our role and our responsibility to live our lives in the position that God places us in and under His authority, then the sooner we don't have to deal with, it's not fair, it's not my place to do this, it's not my responsibility, because we realize that while God loves all of us equally, loves us with His whole passion, we all have different giftings, different responsibilities, different requirements that are placed on each one of us. So we're going to go ahead and remember how to solve linear inequalities, and they're very, very simple to do. And they're going to work very similarly to how we solved equalities. So if you have an expression that says A is greater than B, and that just ended up being written as a 5, even though my mind said B. What's going to happen if you have the expression if A is greater than B? Well, if A is greater than B, then A plus B, then A plus C is going to be greater than B plus C. And since subtraction is the inverse operation of addition, we don't even need to go back to state where we said in Algebra 1 that if you have A, if C, can't even say the right letters today, if A is less than B, then A plus B is less than A minus C. But when you have an inequality, it doesn't matter if it's A is greater than B, A is less than B, A is greater than or equal to B, A is less than or equal to B. Those are inequalities because they have, instead of it just being X is equal to one specific number, you have a variety of numbers that value can be. Regardless of whether you are adding or subtracting, you follow the same rules with an inequality as you do with an equality. If you've got an inequality, as long as you add the same quantity to both sides of the inequality or subtract the same quantity from both sides of the inequality, the truth of your inequality holds true. When this comes in, and it's different, is when we're dealing with the multiplicative or the multiplication property of inequality, and that's when we get those differences. And it's just this one time. So if we have an inequality again, so we're just going to say this is multiplication. Multiplication implies division because division and multiplication are inverse operations that undo one another. So if you have a given inequality, and if you multiply it by a positive number c, a times c is less than b times c if, and only if, c is greater than 0. What does that mean in English? Well, this is saying that if you have an inequality where one side is less than the other, one side is greater than the other, if you multiply both sides of that inequality by a positive value, if you multiply that by some value where c is greater than 0, then the truth of that inequality remains. It's still if a is less than b, then a times c is less than b times c. However, if you multiply by a negative value, then the direction of the inequality changes. If c is less than 0. So this one right here, when you multiply, and I'm going to go ahead and write division here just so that you remember. With a positive number, and I left out a syllable, positive, this inequality holds true. And you see, I'm not going to circle it because I don't have a different color marker right here convenient, but the direction of the inequality doesn't change. However, once you multiply both sides of the equation by a negative number, or that is by a value c that is less than 0, then the inequality, the direction of the inequality reverses. Direction of inequality reverses. A is less than b. If you multiply by a value that is negative, by a value that's less than 0, the direction of your inequality reverses. These are dead review, not dead, just straight total review from Algebra 1. Remember, the only time that the direction of an inequality is going to reverse is when you multiply or divide by a negative number. Adding or subtracting a negative number has nothing to do with the direction of the inequality. I could take time and go through and show you examples, but I'm not going to do it because I know that you have enough videos to watch anyway. Now, let's go ahead and do one of these problems. I'm going to surprise you and give you a present of a very small video. So that instead of you thinking, oh my goodness, here comes 10 more videos, you have one video that's very short. Let's say that we want to solve and graph this. This is example number 2, and you can find this on page 48 of your text. Solve and graph. 2 times the quantity x plus 9 minus 6 times the quantity x plus 2 greater than or equal to x minus 3. First thing that you do here is remember order of operation. We're going to have to distribute. 2 times the quantity x plus 9 gives us 2 times x, plus 2 times 9 is 18, minus 6 times x plus negative 6, times positive 2 gives us a minus 12, greater than or equal to x minus 3. Remember, you distribute a negative sign. The signs of each term inside those parentheses reverses. Now we're going to collect like terms. Negative 6x is not the answer. Negative 6x plus 2x is going to give me a negative 4x. Negative 4x, 18 minus 12 plus 6 is greater than or equal to x minus 3. Okay? Now, we have x's on both sides, constant terms on both sides. Let's just go ahead and move our x to the left-hand side, put our constant terms on the right-hand side. So I'm going to combine the steps. 4x minus x plus 6 minus 6 is greater than or equal to x minus 3 minus 6. What I did, we wanted to eliminate the x on this side, so I subtracted the x from both sides of the equation here and here. That shows that I subtracted the x from both sides, which will eliminate the x on the right. Now, I also wanted to eliminate the positive 6 on this side of the equation, plus 6, so I subtracted a 6 here, and I subtracted a 6 on this side of the equation. I collect like terms together. Negative 5x is greater than or equal to a negative 9. So I don't care about negative 5x, we only care about 1x. We're going to multiply both sides by the reciprocal, or divide by negative 5, divide by negative 5. What am I doing now? I'm dividing an inequality by a negative number. Means the direction of the inequality must reverse. So we have x is greater than or equal to a positive 9/5. Remember I just said it has to reverse greater than or equal to, and I said it has to reverse greater. Well, I didn't reverse it, did I? X is less than or equal to 9/5. When you multiply or divide both an equation and inequality by negative numbers, we did here, the direction of the inequality is going to reverse. So we have here, x is less than or equal to 9/5. The question also says, let's graph this. At the same time, let me see where I can put this. I guess I'll put it over here. And I'm just going to sketch this very roughly. 9/5, negative 9/5. Is that whole thing on there? Yes. How do we graph this? We locate the point. That's 9/5. Because we have the equal sign, the point 9/5 itself is included in our problem. And this says that anything less than 9/5, all of this stuff, everything going towards infinity in the negative direction is the part of our solution. So what we have right here, this part that's all colored in, this is what our solution is. Includes a point 9/5. Every value that extends towards infinity in the negative direction. And you know that this is how you graph this inequality here. What you might not know is that this is called an interval of real numbers. So this is a little bit more vocabulary to help you understand what's being talked about in your math texts. It's real numbers because it's including every single number between 0 and 9/5. It's just not 9/5 and 0, but it's all of them from 9/5 and less, but it's an interval because it doesn't include the entire set of real numbers. That's all that there is to section 2.2. I think this showed by taking one of the more involved problems for this section. I don't see where there's a better reason to take up any more time. So that is a record for Algebra 2 videos.